Hi friends, I hope everyone is doing good and welcome to my channel. Today we are going to solve another interesting array related coding problem. It's on Leetcode 2540 minimum common value. So let's start. Given two integer arrays nums1 and nums2 sorted in non-decreasing order, return minimum integer common to both arrays. If there is no common integer amongst nums1 and nums2, then return -1. Note that integer is said to be common to both the arrays if they have at least one occurrence of that integer. Okay, so we want to find out such a minimum common integer, right? This minimum is important word here. Okay, so common is important obviously, but minimum is another important thing. So nums1 dot length, nums2 dot length can be maximum 10 raised to 5, and the numbers so it can be very larger, and the numbers will range between 1 to 10 raised to 9, and they are already sorted in non-decreasing order. Okay, so these are already sorted arrays. So let's take a look at some examples to understand this better. So 1 to 3 is here, 2 4 is here, so minimum number which is common is 2 here, right? 2 is the minimum number common. In the second one, 1 2 3 6 and 2 3 4 5, again 2 is the minimum number which is common. So that's what we want to find out. I created some examples for you guys. So here 1 2 3 4 5 6 7 8 and 5 6 7 8 9 10 11 12 13 14. So now the minimum number which is common here is 5, right? 5 is here also and 5 is here also. So this is why it's 6 is also common, 7 8 is also common, but we want to find minimum, right? Minimum. So 5 is the minimum one. This is another example. In this case you will see that the minimum the minimum one here is 13, right? 13 is the minimum one which occurs in both these arrays, right? 14 is also common, but it's not the minimum one. So that's what we want to find out. So now you understood the problem clearly, right? So now how we can solve this problem? So what we can do to solve this problem is we can go through this. Now important thing to understand is these are already sorted arrays, right? So both are sorted, so we don't have to do any sorting. We can take from this first number and we can apply on this second array. This is the second array. We can apply a binary search, right, on the second array, and we will try to find out if one exists in this array, right? So there is no one exists here, right? So one is not there, so you will go to the next one. So 2, you will again do a binary search, it's not there, so eventually you will go to 13, right? Eventually you will reach here, right? So 1 2 3 4 you tried, it did not exist, so now you are trying for 13. How binary search works? You put left pointer here, right, and you put right pointer here, right, and you go to the middle value. So let's say middle value comes here, right? Okay, so you go to the middle value, you will check if this 10, right, 10 is smaller than 13. So it means that if 13 exists, then you should go to the right side, basically, correct? Because 10 is smaller than 13, then what you will do, you will put your left pointer here, right, and you will again go to the middle value. So let's say your middle value is coming to 13, right? Let's say, right, we are just discussing the concept. Okay, so the pointers may go one bit here or there, so that's not important. You will go again here in the middle value, let's say, and you will check that this middle value is actually what you are looking for, right? So you will just directly return the value. And how will we assure that it's minimum? Because these are already sorted arrays, guys. You understood, right? How will we assure minimum? Because these are already sorted arrays. So the first one that you find out is the minimum one only, correct? Because 14 is common, but you will never go there, right? On 13 only you will find that value. And binary search takes log of n time, so it runs on a logarithmic time complexity. And the important thing is you don't need any extra space, right? In the many times in the interviews they will ask you not to use extra space. Okay, extra space you cannot use, then in that case this binary search is very handy technique, basically, correct? So that's why I wanted to show you this today. You can solve this problem in lots of other ways. You can use set and external memory, but here you don't have to use any external memory using a binary search. So I hope you understood this concept of binary search and how we are applying it here on this particular case, right? So we'll go to the Java code and I'll show you the Java solution so it will be more clear for you guys. So this is the problem, this is the Java solution that we have. So get common is the method we are implementing. nums1 nums2 arrays is given to us. So for I is equal to 0, I is less than nums1 dot length I plus plus. So you will check each ith number. So target is the number you are checking using binary search, right? Nums2 and target. If this value is not -1, then you will directly return value. It means that you found that value in the second array, correct? If you come out at this end, it means that you never find out any common element. In that case, you will return -1, guys. Right now, I'll show you a binary search. Here, what you are passing nums2 array, and you are passing the target value that you are searching in that nums2 array. Okay. So this is a typical binary search implementation where your start is 0, end is equal to array.length -1. Start is less than equal to end, you calculate your midpoint, right? By start plus end minus start divided by 2, and you check your midpoint. If it is less than what you are looking for, your target, then it means that you want to go to the right, basically, right side you are going basically here, right side. If your mid value is actually greater than the target, then it means that left side you should go, basically left side, right? Okay. And else it means that you actually found the target, basically, right? You understood, right? Less is not there, greater is not there, it means that actually it's equal, then you will return the target. If you come out here at the end, it means that you never found out the target, you will return -1, correct? So this is the binary search. So this binary search implementation is a logarithmic time, so it's a log of n, correct? It's a log of n. You are doing it maximum n number of times in this for loop, so it is n log of n time complexity, guys. N log of n time complexity. Okay. And on the space, you have not used any extra space here, right? We didn't use any arrays, linked list, array list, hash map, hash set, preset, nothing. It means that this is a constant on space solution, right? So this is why I wanted to show you how the binary search can help you without using any external memory, right? You can solve this problem easily with set and other things, but that's not what I wanted to show you. That's why I'm creating this video, guys. So we already talked about the algorithmic complexities. Now is the time to test this code with some test cases, and I have created these 2 test cases also here. So let me show you this. So this is the test case that we just saw, right? So here 13 is the correct answer, this is the one, and in this case I created, which is a 5 is what we are looking for. 5 is correct answer. These are other test cases, correct answer and correct answer. Submit this code to the Leetcode, make sure the code gets accepted by the Leetcode. And as you can see on your left side, the code is successfully accepted by the Leetcode. I'm not very sure about these numbers, but this is how you can use the binary search way to solve this coding problem. It's on Leetcode 2540 minimum common value. So I hope you like this binary search solution, and these are the examples, guys. It takes a lot of creativity, time and efforts to come up with these examples. So if you really want to appreciate our efforts, then try to be generous and definitely give a like for our video and subscribe to our channel. Your subscription is really valuable for us. Click on the bell notification icon button so you won't miss any interesting upcoming videos from our channel. Share these videos with all your friends so they can also watch and learn different ways of problem solving, Java programming and coding. On this channel, we have more than 600 different varieties of solved coding problems available here. Those are important ones asked by big companies in their interviews, such as Amazon, Apple, Microsoft, Yahoo, Google, Meta, and lots of big companies. And we compiled playlists for you. We have sorted problems according to different types, and the important playlist that you should watch right away includes graphs, matrices, binary search trees, binary trees, problems solved by using binary search, dynamic programming, recursion, memoization, how to use and apply DFS and BFS on graphs, matrices and trees. The important data structures playlist we have created for you guys includes stacks, queues, priority queues, min heap, max heap, arrays, array lists, linked lists. So everything is here, guys, so don't miss out on those important solved problems. If you are a Java consultant, then we also have created important videos that discusses frequently asked Java telephonic interview questions and how to answer them. It captures all the important core Java questions related to Spring, Hibernate, JPA, and other auxiliary Java technologies. We also have a lot of MySQL coding problems available for you here. Those are the questions asked in the interviews, right? So go through them, they will definitely be helpful to you. And if you like this binary solution, then definitely give a thumbs up and give a like for our video, and don't forget to subscribe to our channel. Thank you for watching this video. Have a great day ahead.